So we doing okay with this stuff? So we have just that direct relationship between height and pressure. Don't make it any more complicated than that. Okay, and then okay, so 1 foot is 0.433 psi. And then you can use that relationship there to measure pressure in pipes using what they call a piezometer. And I remember back when I was in school, they were doing some hydraulic testing, and they had these things. They were filled with this red oil, is what I remember, so they could read them. Okay. All right, and then we started to look at atmospheric pressure a bit. And what we figured out here is that if you put a closed tube of water and you turn it upside down into like a vat of water or a tank of water, what's going to happen here is that the water in that tube will rise 34 feet, okay? So we figured that out, and that has to do, if the tube were a square inch in area, that atmospheric pressure is 14.7 psi. You'll get a vacuum at the top of the tube, so there's no push back at the top of the tube. So the atmospheric pressure pushes on the water. All those water molecules push on each other, so you end up with a push going up the tube that holds up 14.7 pounds of water. And if you work that out for a 1 inch square tube, that comes out to be 34 feet. Okay. So we okay with that? All right, and then we also looked at absolute pressure and gauge pressure. Gauge pressure is the everyday average pressure that we deal with. Absolute takes the gauge and adds atmospheric to it. Okay. So those are some of the things that we worked out. Okay. All right. So what we've got now is we've got a few ways of looking at things. Atmospheric pressure is 34 feet of water. It's also, what, 14.7 psi, A for absolute. Now, in reality, there wouldn't be a perfect vacuum at the top of that tube. There'd be a little bit of vapor pressure. Now, we'll get into this more when we look at pumping, so we won't really discuss it too much more, but in truth, there'd be some of those water molecules in the tube would evaporate, and they'd start creating a little bit of a pressure that would push that column down a little bit. Not too much, but a little bit. But we'll get into that later. Okay. All right, now what we've got here is a few relationships now. So what we've got is that 14.7 psi is equal to 34 feet of water. Okay, they're equal. They express the same thing, the same pressure. Now what you can do is divide both sides by 14.7, if you like. And what you'll get is 1 psi equals 2.31 feet of water. And this is on your formula sheet also, I think. And that's another relationship you can use to do conversions with. So we've gone both ways with that. We also have that 0.433 psi is equal to 1 foot of water. We can go either way with it. Those are just reciprocals of each other, go in different directions. Okay. So those are equivalent things. And I think you've got both conversions on your formula sheet, if I remember right. We do. You do? Okay, great. So that's there for you if you need it. All right, now getting back to this idea of a barometer, you could make a barometer out of water and the thing would be 34 feet high. And, they actually used to have barometers that were filled with fluid and they measured the height of them to determine atmospheric pressure. But a 34-foot high barometer is obviously pretty impractical. So what was commonly used was mercury. Mercury is a heck of a lot heavier than water. It's 13.6 times as heavy as water is. So if you take that 34-foot water barometer and divide it by 13.6, you get 2.5 feet, which is 30 inches. So atmospheric pressure can also be described in inches of mercury. Average atmospheric pressure at sea level is 30 inches of mercury. And, they actually used to use gauges like this and measure them. And if you ever listen to the weather report, they'll report the barometric pressure, they call it. That's from a barometer, and they'll tell you how many inches of mercury it is. That's the common way they use to report weather. Okay.
That's where that number 30.29 comes from.
Yeah, right.
As it goes down.
Yeah, and they watch, and right, the barometer goes up or down depending on what sort of weather system's moving in. If the barometer drops, you probably got some. Yeah, right. And the lower it goes, you're likely to have storms and weather like that. High pressure systems are more clear and sunny and bright, And that's that number really comes from an actual barometer. That's where that comes from. Now those things are obsolete now, but they still use the term. So it's kind of gets a little complicated in a way because there's 3 ways to measure atmospheric pressure. Atmospheric pressure, average atmospheric pressure is 14.7 psia. It's 34 feet of water, and it's 30 inches of mercury. Okay, so you could use any of these, and they're all used in different situations. And again, you've got that on the formula sheet, and it's in the left-hand side in the middle, and also I've got a bit of a chart there that kind of helps keep these things straight. Okay. So now often what we use all this stuff for in our line of work here is measuring a vacuum. So a vacuum is a pressure less than atmospheric. So if you measure from absolute pressure equals 0, which means like a perfect vacuum like you've got in outer space, you can measure a vacuum in psia, absolute pressure, a water barometer, or a mercury barometer. Those are 3 different ways you can measure a vacuum. Okay, and that assumes that the perfect vacuum, absolutely no pressure at all, is 0, and you're measuring up from there. Okay. You can also measure a vacuum from atmospheric pressure, calling that 0. And then if you're doing that, what you would measure the vacuum in is negative psig, gauge pressure, negative, a water vacuum, or a mercury vacuum. Okay? So you can measure a vacuum, as it turns out, in 6 ways. There's 2 different 0 points. Either 0 is a perfect vacuum, or 0 is atmospheric pressure. Okay? So you got 2 different 0 points. This is like for gauge pressure, 0 is atmospheric pressure. Okay, and what you do to measure a vacuum then is you measure down, is what you do. So if you have gauge pressure, let's say, you'd measure down like that. If you have a water vacuum, you'd measure like that. And if you have a mercury vacuum, you'd measure like that. Okay, they're all measured down. The word vacuum on a measurement means it's a negative number, okay? Measuring down. Now, the other way to measure a vacuum is to start at a perfect vacuum, being 0. In that case, your measurements go up. You always count your measurements from 0 to whatever it is you're going to. Okay? So that's how I think about that chart. So if the measurement is right there on the yellow highlighted line, you'd measure it as shown. It's always from 0 to the measurement. Okay. And there's three ways to measure: water, mercury, and psi. And you can either measure them down from atmospheric or up from a perfect vacuum, either way. Okay. And we just want to be able to convert these from one unit to the other, just depending on what we've got, because we seem to use all of these things in different situations. But the one thing to remember on this is you always start at 0 and measure to the line, either up in the case of perfect vacuum being absolute vacuum, or down in the case of atmospheric pressure being 0. Okay. So you start at 0 and measure to your line. This is one way to do these conversions. To me, it makes it kind of handy. Okay. So let's do an example here. Let's say we got 24 feet of water barometer, and we want to convert that to psia and inches of mercury vacuum. Okay. So what I would do here is I would go to this little chart, and I go, okay, where's 24 inches of water barometer at? Okay. 24 feet, yeah, my bad, thanks. So 24 feet of water barometer. Okay, where that's at is on the water barometer column there, the 1, 2, third one over from the left. Halfway for that is 17. So my thinking is 24 ought to be about there. So here's where 24 feet of water barometer is on that chart, okay? That's its location. Now, I'm going to have to convert to a lot of different units. So what I do, and again, you can do this, there's many ways to do this. This is just a kind of a systematic way to do it, is to figure out what percentage of the way on that scale are you. Okay, what's the percentage of the total that you've got? Okay, so I'm going to take 24 feet of water, is what I'm going to do. And I know the total is 34. So if I divide those out, I've got 70.6 is what I've got. Or 0.706, I should say. I should have that as a decimal. So the idea here is underneath the yellow line, I've got 70.6%, and above it, I've got the remaining percent, which would be 29.4%. Okay? So I'm 70.6% of the way up the scale. That's the idea.
How do you know it's 34?
34 is the total.
Oh, total.
Yeah. Okay. And you know, the total varies depending on which unit system you're in. Okay. So you all okay with that? Okay. So what I want to know now is, you know, what other units do I want to convert into? Okay. And so what I want to convert into is psia. And inches of mercury vacuum is what I want to do. All right, so psia, let's see where that is, okay? So with the water barometer, I came up like that from the bottom, because you always start at 0 and measure to what you want to find. Okay, psia, where are they at? They're right here. So I want to measure from the bottom up for psia, like so. And then inches of mercury vacuum, what I want to do is find that, okay? So inches of mercury vacuum are right here, and from there I'm going to start at the top and measure down, okay? So you always start at 0 and measure to your line. That's the general rule on this stuff. So for the psia here, what I'm going to do is I'm going to say, okay, I've got 70.6 of the way to go. So that's 0.706. And the total is 14.7. So if I take 70.6% of 14.7, I get 10.4. So that's the PSA I've got. And then if I want to find the inches of mercury vacuum, what I've got on the top of the line where the red arrow is, right here, is that's 29.4%, so that's 0.294. And then mercury vacuum is 30 inches. So when I multiply that out, what I get is 8.82 inches. Hg is the chemical symbol for mercury. Okay. So by using this chart, I can kind of figure out which side of the horizontal line I am for my particular measurement. I can find the percentage on either side, and I can apply that to the total scale that I'm dealing with. Always start at 0 and measure to the line. Everybody okay with that? All right. Now there's other ways to do this if you like. I mean, this is just a graphical way that, you can see it. I put the chart there on your formula sheet, so you can use that on homework or exams or whatever, okay? It's right there. There's other ways to do it, though, if you prefer. I mean, whatever works for you is fine. Okay. All right. All right. You two can do this, so why don't we have a look at the next one there. Convert 20 inches of mercury vacuum to psia and psig. So why don't you work through that? I don't know if it is exactly right there. I'm just drawing the line about the spot. Here's 17. Here's 34. So I know somewhere. It doesn't matter that I put it in the spot.
But it's going to matter for this.
Well, it matters that that's really what I want, those numbers. So if I just draw the line anywhere here between 17 and 34, because I'm going to do the calculations to calculate. So it doesn't have to be drawn.
And this is the choice. So mercury.
So just pay attention to what side the zeros are.
That's the back end.
Yeah. I'll figure out the percentage of mark, of where that was.
So it'll be
Still have a copy of the percentage. Figure out the 2 you want to make. That's the one that zeroes out up here. And then, you see the 66 back 7 is up here. That's what
Oh, did you? Nice. When you started with it?
Yes.
Oh, right, yeah, okay, now. Excited? Oh, God. You're gonna yell at you, I'm gonna go on dance and everything.
So, you just do the same form?
Yeah, yeah. The first thing our signature was yeah. Yeah, I hope you're.
So you essentially get the same answer one time.
There goes,
Yeah. Sure. Big picture to everything.
Right, and it's because on the pressure, yeah. Whereas on this one, you're starting point.
I know, I'm saying like this. Yeah, so if it starts from 0, you get 30%. It starts from 0. I lost this was easy. Yeah, so control it at 5.
Doing all right on that? I got 4.90 psia and negative 9.8 psig. Is that all right? Good. So, you know, I draw that horizontal line in at for the mercury barometer. Okay, and that's 20. All right, so that's where I started. All right, hang on, that was mercury vacuum. There we go. I'm sorry, mercury vacuum. So that's 20. Right there. So that's 20 inches. And that's down because the vacuum means negative. So that starts at 0 and comes down here. The line's right about there. So 20 over 30 is 0.667. That leaves 0.333 on the other side. And then I just look at psia, starts at 0 and goes up, so that's 33.3%. psig starts at 0 on the top and goes down, so that's 66.7%. And then the psig, just remember that's a negative because a negative psig is below atmospheric. Okay. Good with that? Okay. Okay. So that's another type of pressure problem there, okay? Okay, and then another thing here is manometers. Now, manometers are tubes, again, that are filled with water or filled with a fluid. Now, quite often these are used, the common ones are U-tube manometers. So what they do is they measure the pressure difference between two pipes. So the idea is that you've got the pipes are running in and out of the page here, and then you put this glass tube between them, fill the glass tube with usually a pretty heavy fluid, something like mercury or something like that, and then based on that you can tell the pressure difference between the two pipes. So the pipes are coming in and out of the page kind of like that. Okay. And then the manometer tells the pressure difference between the two pipes. That's the idea.
And the side of the pipe that has the lower water level has more pressure?
Yeah, because it's pushing the heavy fluid towards the other pipe. That's the idea. Okay. Any y'all working in plants still using these anywhere? Anybody seen one of these? Yeah, okay. They're old technology. I mean, you know, the new stuff's all digital. You know, okay. So what you can do, you can use this to tell the pressure difference between two pipes. Now, what you do is you look at how much mercury is being held up, but you also want to look at how much water is being held up too. So you want to look at both of those things, and that's how you determine the pressure difference. So here's how I would approach this thing. Now, in your book, you've got 36 and 24, a little bit different than the sketch I've got, right? So you've got 36 on, or 24 on the left for this one. And 36 is the total, right? Okay. All right, so the way I look at these is I go, okay, what's different about what the two pipes are doing? So what's happening here is the pipe on the left is pushing water towards the pipe on the right. Okay? Or pushing the mercury, I should say. All right, so if I look here and look there, the difference is between the two red lines. Above the top red line and below the bottom one, everything's the same. So the difference is here. So those are A and E are the names of the pipe. So to keep this simple, what I would do here, I would just look at what A is doing towards E. And what A is doing towards E is it's holding up 24 inches of mercury. And then what would we do with that? We would go, and I guess the first thing we better do here is get this into feet, okay? Hg is the chemical symbol for mercury. That's why I'm labeling that Hg. All right. So I'm going to go 2 feet of mercury. And then I know that 0.433 psi per foot is my conversion for water. And I know that mercury is 13.6 times as heavy as water. There's other ways you could do that conversion, but that's how I'm doing it, because I know that mercury has a specific gravity of 13.6. So what that's going to give me is the psi of mercury that would push up, if it were pushed up 2 feet, that would be the equivalent of 11.78 psi. Okay. Now I do have to account for the other side though, because there's 2 feet of water being held up by E towards A, and I have to account for that. See, A is not, it doesn't push that 2 feet of water towards B, it pushes the mercury. So I'm going to have to subtract this off. Okay, and so when I run the numbers on that, I'm going to get negative 0.87. So what's happening is A is pushing 2 feet of extra mercury towards E, but E is pushing 2 feet of extra water towards A. So the difference is what I want. And that comes out to be 10.91 psi. This is about the first year that no one's seen a YouTube manometer, so you know how much longer we'll keep covering these. But you know, we were using these back, you know, when I was in school and all that. But they were still somewhere around, mostly in wastewater plants. Is what people were telling me, but maybe not anymore. But the thing on this is, you know, you're pushing 2 feet of mercury towards from A to E, but there is this 2 feet of water that's different between the two sides. So that's what E pushes towards A. So you got to take that away. You get the difference.
You don't calculate the weight of that water, just the pressure.
Yeah, just the pressure, because that's what we're looking at, is a pressure difference. Okay. So we good with that? Any questions? Okay. All right, you know, so those are the old ways of measuring, or some of the old ways of measuring pressure. There's also something called a Burden gauge. And what a Burden gauge has is, you know, it has a dial face on it with a range of pressures. It then has a diaphragm made out of some sort of metal that'll flex a little bit. I think copper or brass are fairly common. Copper, I think. So if you pressurize this little arc of metal, it'll try and straighten out. Then you run some linkages in there and turn the dial with that. So you've got these, this tries to straighten out, and the linkages then turn the dial. That's the idea. All right, so this is an analog gauge, it's not digital. So that's another way to measure pressure. Now, if you're going to use this gauge, what pressures would you trust it for? Or what pressures would maybe not trust it for? Whatever you want to think about it. Does that thing measure accurately from 0 to 15 psi? Okay. Where do you want to use this thing for, though? See, these things are a little tricky. They're not, think about the engineering that goes into doing this. You're taking the flex of a tube and converting it into a pressure. That's
Not exactly accurate.
you're right. That's a little hard to do. I mean, it's a cheaper gauge, but you are sacrificing a bit of accuracy. Where's the range for which it's most accurate, though? In the middle, okay? And I don't know exactly what the percentages are, but I wouldn't want to be using this gauge for low readings. It's not going to be super accurate down there, nor is it going to be super accurate near 15. I'd estimate, 3 to 12 or something like that. So when you're using these things, try and stay in the middle of the scale. Consider getting a different gauge if you're not, So generally you want to be using those kind of, in the middle range. Okay. All right, have you all in the water program, have you taken that water sources class? Did you go out and look at the wells we got on campus?
You can go look at them, talk about them.
You talked about it, you didn't look at them.
We looked at the sheet that was right when they were put in.
Yeah, well log and all that. Okay, but you didn't run any testing on it or any of that. Okay. Well, do you know what a drawdown test is? Okay. Okay, so what you want to know with water wells is how deep they are. And that is something you got to be careful about, because if you put too many wells in an aquifer, you start pulling more water out than it's coming back in. The aquifer is going to start dropping and dropping and dropping, and that's trouble. Okay, so here's one way of measuring the depth of a well. What you do is you get a little air supply, and you push water through a copper tube that extends down into the well below the water surface. You know how deep the copper tube is, in this case 100 feet, and you push air out the bottom of the tube with your air supply, okay? So what you're going to do, these are called bubbler gauges sometimes because they got little bubbles of air that they push out the bottom of the gauge. All right.
Does that make it easier for the water?
No, I don't think it really makes much of a difference. It's not a whole lot of air, but they just push a little bit out, so they just get kind of a stream of bubbles coming out of it. And what they measure with that pressure gauge is the back pressure. Okay? So they're going to measure a pressure over here on the gauge is what they're going to do. And if you measure how much pressure it takes to push the air out, you can figure out how deep the well is if you've got the other data. So if we've got 26 psi there, how many feet of water does that represent? So 26 psi. 1 psi gets you 2.31 feet. Yeah, 60 feet. So if that gauge reads 26 psi, that's how much water is above the tube. .1. Now what you got there, you put 100 feet of tube into the well. You know what's called the casing of the well. That pipe is 2 feet above the ground. Okay. So you want to subtract that off, so that tube sticks 98 feet into the water. And you know that you've, that there's 60.1 feet of water above that tube. So what's the depth of the well here? Depth of the well being this. Yeah, 37.9 feet. Okay.
Are we assuming here that that tube has gone all the way to the bottom of the well when they're doing that?
No, it just goes down. They're confident that the water won't ever go below the tube. So it doesn't have to go to the bottom because we're measuring everything from the top. All the measurements are down.
Measuring there is how much water is in the well down to 100 foot level. You're not measuring the actual depth of the well.
Well, the depth though is measured from here down as opposed from the bottom up. So you want to know, because as that drops, that means you're using one more water. So the reference point is up top. All right, and I don't know, nowadays, again, they probably put a pressure transducer down there. That is one thing with all the electronics these days. If you look at like older cars, they have all these really innovative, tricky little mechanical devices, pneumatic devices to do things. Now it's all kind of replaced with a computer chip and all this stuff. All these little elegant solutions to these problems have been kind of replaced, I think. But there you go. So that's another use of this pressure stuff. Okay. All right. So that one basic fact there is that 1 foot of water is 0.433 psi. 1 psi is 2.31 feet of water. And then we also did that stuff with atmospheric pressure. That's really the basics of this. Okay. All right. So why don't we have a look at what you could be doing next here for next week. So this stuff, maybe we'll make this due Monday. And let's see what all it will be. Get here, course available to students. Okay, there we go. All right, and remember this stuff's in Moodle, okay? So this will be out of chapter 7. And this stuff will be due Monday, which I think is the 9th. What, it's the 4th, 6th, 7, 8, 9, yeah, the 9th. So we got 7, no, you won't be able to, well, let's see, how should we do this? Okay, the stuff's right in there in Moodle. So it's quite a few problems here. So we got 7.1, and I've got the answers to them in Moodle also, so remember that. So what have I got? I got 7.1, 7.2, 7.3, 7.4, 7.5, 7.6. So we got a few more this time. 7,
7.1, 7.11.
Thank you. Simpler way to write that.
Chapter 7.
Yeah, so it's all of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 7.1 through 7.11. There we go. And these will be due Monday, okay? So we'll go over them Friday, and I record these sessions, and I'll record the one from Friday too, of course. All right. Cool.